For today's lesson, we will be discussing about the product rule of differentiation. So last time we discussed about the basic differentiation rules. So this time we will continue our discussion about derivatives and we will focus more with the product rule of differentiation. So let's discuss what is the product rule. So let f and g be differentiable functions. It follows that the product fg is also differentiable. Its derivative is given by d over dx of f of x times g of x is equal to the product of f of x and g prime of x plus the product of g of x and f prime of x. So unlike with the sum or difference rule wherein if there are terms or functions that are added or subtracted together, you can just get their derivatives individually and then add and subtract the sum. But for multiplication, we have to follow the product rule, wherein you have to multiply the derivative of one function to the other one and then add it to the product of the derivative of the first function and then the other function. Now, to make it a bit simple, we can just refer to as the f of x as u and our g of x as v. So this will just help us to easily remember the product rule. Now take note again, u and v represents the first and the second functions, or the first and the second terms being multiplied together. So to get the derivative of that, we can just follow the format or the pattern u dv plus v du, so that you can easily remember the product rule. Now, what do we mean by u dv and v du? So when we say u, all you have to do is just to copy the first function or the first term. dv means you have to get the derivative of v or derivative of the second function. So it's the same as this one. And then plus v du. V means you just have to copy v or the second term or second function, and du means you have to get the derivative of the first one. So this will help you, the u dv plus v du, to easily remember the pattern that we are following for our product rule. Again, remember, u and v refers to the first and the second term or first and the second function in the given. So let's try this with this example. F of x equals the quantity of x cubed plus 2 times the quantity of 4x squared plus 6x. So we have here two binomials that are being multiplied together. And then what we will do is we will set this as our u and then we set this as our v. So we have the first and the second term. Now we can apply the pattern u dv plus v du. So let's write here f prime of x is equal to u dv. So u, you just have to copy the u, which is x cubed plus 2, dv, so derivative of v, which is 4x squared plus 6x, and then plus, now you have here v du. So v, copy v, which is 4x squared plus 6x, and then du, or get the derivative of the u, which is x cubed plus 2. So again, what we applied here is the pattern for our product rule, which is u dv plus v du. So before you do this, you have to identify first or set first which one is the u, which one is the v. Then after that, we can now simplify this. So we have x cubed plus 2. Get the derivative of v. So we have here 4x squared. The derivative of that is 8x. So we applied here the constant multiple rule and also the power rule. So just multiply 2 and 4. You have 8. And then subtract 1, 2, 2. So you have x only. Plus, and then this one is 6. So the derivative of 6x is 6 only. Plus, then we have 4x squared plus 6x times the derivative of this is 3x squared. So we apply the power rule and also the constant rule. And then after that, after you get the derivatives, next thing that you have to do is just to multiply the terms. So let's multiply this 2 first. So that will give us 8x raised to 4 plus 6x cubed plus 16x plus 12. Again, all you have to do is to multiply, so you can apply the FOIL method. Plus, and then do the same thing for the other pair. So we have here 12x raised to 4 plus 18x cubed. Now, after you multiply the terms, last step that we can do is to combine similar terms. So, combine 8x4 and 12x raised to 4. That will give us 20x raised to 4. And then we have 18 and 6x cubed. That will give us 24x cubed. And then plus 16x plus 12. So there. So this is now the derivative of our function using the product rule. Next example, let's say we have f of x equals 5x squared times x squared plus 2x. Again, what we want is to use the product rule. So let's set this as our u and then this one is our v. And then we can again apply now the u dv plus v du. So you have u, which is 5x squared, dv, so derivative of our v, which is x squared plus 2x, plus, and then we have the v du, so v, x squared plus 2x, times the derivative of our u, which is 5x squared. Now, let's get the derivatives of our function. So we have 5x squared times derivative of x squared plus 2x, so that is 2x plus 2. We use again the power rule here. For 2x, we also use the power rule, so I explained this already in the last video. Plus, and then we have here x squared plus 2x, and the derivative of 5x squared is 10x. After that, let's again multiply. So we have 10x cubed plus 10x squared, plus, multiply also this 2 right here. We have 10x cubed plus 20x squared. And then lastly, all we have to do is just to combine similar terms. So we have 20x cubed plus 30x squared. So there. So this is now the derivative of our given function. Now, let's say you're not asked to use the product rule. Actually, you can already get the derivative of this without using the product rule. What you can do is you can just simply distribute 5x squared to x squared plus 2x. So that will be 5x raised to 4 plus 10x cubed. And then from here, you can already get the derivative using the sum or difference rule. So use the power rule and constant multiple for 5x raised to 4. That will give us 20x cubed. Plus, and then this one will give us 30x squared. So as you can see, they are just the same with one another. So if you're asked to use the product rule, so this is the first thing, or this is the one that you will do. But if you're not asked to use the product rule, or there's no specific rule to be used, then it's up to you what technique are you going to use. So you can try this one. As long as you are applying the rules correctly and everything is mathematically correct, so you can do it. Again, as long as there's no specified technique that you have to use in getting the derivatives. Next, let's have y equals a quantity of 2x squared minus x squared. So as you notice here in this example, we just have one term, which is 2x squared minus x, but it is being squared. Now, again, I want to use the product rule here. So what we can do is, we can just simply separate the 2x squared minus x squared. So this is just equal with 2x squared minus x times 2x squared minus x. Remember, if a certain value is being squared, that means you just have to multiply it by itself. So that's why we can just write it separately like this. And then this is our u. This will become our v. And then from here, we can now apply the product rule. So we have y prime is equal to u, 2x squared minus x, derivative of v. So 2x squared minus x plus v times the derivative of our u, which is 2x squared minus x. And then, we can now get the derivative. So 2x squared minus x. Derivative of 2x squared minus x is 4x minus 1. plus, and then we have 2x squared minus x, same as with the other side. This is also 4x minus 1. And then from here, we can now just simply multiply this 2. We will get 8x cubed minus 6x squared minus or plus x plus, and then it will be just the same as the other one. So 8x cubed minus 6x squared plus x. And then from here, we can now just combine similar terms. So we have 16x cubed minus 12x squared plus 2x. So this is now the derivative of our function. And for our last example, let's say we have g of x equals quantity of 1 plus x times the quantity of 2x minus 7 times the quantity of x squared plus 2. Now, as you notice, we have here three terms, three binomials. And as what we remember with the product rule, it can be applied if we have two terms being multiplied together. Now, to do this, you have a lot of options actually. You can choose any pair and multiply it, or you can choose any pair and then you set it as our u. So what we can do here is we can just simply multiply so that it will be easier. So we have g of x equals, now let's multiply the first two terms, 1 plus x times 2x minus 7. That will give us 2x squared minus 5x minus 7 times x squared plus 2. Again, what we did here is we multiply this 2 right here. But if you don't want to multiply and then you will just set that as our u, what will happen is that we will have a product rule within a product rule, which is still the same, but it's kind of long. So to shorten the process, we can just simply multiply the 2 in the beginning. And then this will be our u, and then this will be our v. So from there, we can now apply our product rule. So u, 2x squared minus 5x minus 7, dv, derivative of v, which is x squared plus 2, plus v, x squared plus 2, times the derivative of our u, which is 2x squared minus 5x minus 7. And then from here, just get the derivatives. 2x squared minus 5x minus 7. So get the derivative of x squared plus 2. So that is 2x. So what we used here is the power rule and the constant rule. Plus, then you copy x squared plus 2. And then get the derivative of 2x squared minus 5x plus minus 7. That is 4x. Use the power rule, also the constant multiple rule, minus 5. And then, just simply distribute like what we did in the previous examples. So we have 4x cubed minus 10x squared minus 14x plus, and then on the other side, we have 4x cubed minus 5x squared plus 8x minus 10. Again, all you have to do is to distribute using the FOIL method. And so you already know it. So you know it already. I don't have to show it step by step. Again, just use the FOIL method. And then last is to combine similar terms. So we have here 8x cubed. And then we have negative 15x squared. And negative 6x minus 10. So this is now the derivative of our function. And we're able to do it using the product rule. Now, in case you don't want to use the product rule or there's no specific instruction for you to use the product rule, what you can do is, this is just an option. From here, you can multiply again x squared plus 2 to this trinomial, and after you multiply, you can directly get the derivative of that using the sum or difference rule. So it is also possible for us to get the derivative of this given function without using the product rule. But again, if you're asked to use the product rule in identifying the derivative, then this is what you will do. So that's it for today. I hope you learned something about the product rule and how to use it to identify the derivatives of our function, and see you next time.